Welcome back, Science 10. Today we're going to look at how to count atoms. If you could find this sheet, the How to Count Atoms review. Some of it should be familiar just from formula writing, but we move on to balancing equations and looking at what numbers in front of a compound or element do. So first of all, we're just going to make a few notes on this piece of paper. So if you look at this first part here, the symbol of an element just simply represents one atom of that element. So if you see, for example, here we have calcium, and there's just one calcium here, so it's just simply one. So one calcium, that's it. A subscript is a number written at the lower right, and with formula writing earlier, we of course saw that that pertains to what's immediately before it. So a subscript is a number written at the lower right corner behind this symbol. The key thing there is behind. If there's more than one element of if there's more than one atom of that element, then the subscript is used to indicate the number of atoms. So this 2 means that I have 2 nitrogens. Oops, so 2 nitrogens. Okay, so that's all that means. 2 nitrogens I have over there, because it applies them to it immediately behind it. Over here, a subscript outside the brackets multiplies all the elements inside the brackets. So once again, the subscript applies to what's immediately before it. So right here, this 3 means I have 3 of these, 3 bariums, and this 2 means I have 2 of whatever is right behind it. Now what's behind it is a set of brackets with a P and 4 oxygens. Okay, so all together here I have 3 bariums. If I look here too, in the phosphate group, the PO4, I have 2 of these PO4s. So think of it as that of having PO4 and another PO4. So there's 2 P's, and of course here I have 2 sets of 4, so 4 oxygens and another set of oxygens gives me a total of 8 oxygens. Okay, so sometimes that's a little tricky when we have brackets, but just think of it as that subscript applies to what's immediately before it. I have 2 groups of PO4s, so the 2 P's, 2 times 4 is 8, or think of it as multiplying the inside numbers by the outside number. Okay? Now, moving on to slowly looking at balancing equations. Here we have a coefficient is a number written in front of a chemical symbol and indicates the number of atoms of that element. So in this case, I have 3 C's. So 3 C's. Easy. Or a coefficient is a number written in front of a chemical formula and indicates the number of molecules of that compound. So over here, this means that I'm going to have 2 H2Os. 2 H2Os. So what that means is I have an H2O and another H2O. So really you can think of it as, once again, multiplying by the number. So if I have 2 sets of H2O, I'm going to have 2 times 2, 4 H's, and 2 oxygens. So 2 H's and whoops. I have to write the and symbol there. And whoops, I guess that's 4 H's, sorry. And 2 oxygens. Over here, this means I have 3 sets of FeSO4. So there I'll have 3 irons, 3 S's, and 3, now each FeSO4 has 4 oxygens, but if I have 3 sets of them, 4, 4, 4, or 3 times 4, 12 oxygens. Okay, so once again, just think of it as how many groups you have. The next one here, copper 2 nitrates, likely the trickiest one of them all. If we just cover up the 4, you can see that we'll have 2 coppers, or sorry, just for every one compound here of copper 2 nitrate, I have 1 copper, 2 Ns, and let's see, 2 sets of 3, 6 Os. But then after you figure out how much is in one of them, multiply it all by 4 because we actually have 4 of them in total. So one of these copper nitrates has 1 copper, but if I have 4 sets of them, that's a total of 4 coppers. So it may be easier to work inside than work out. Covering up this 4 again, if I look at how many Ns I have, 2 sets of 1, so 2 Ns, but I have a 4 in front, so 2 Ns multiplied by 4 is 8 Ns. And lastly, if I just cover up this 4 for a second, 2 sets of 3 oxygens, so 2 times 3, or 3 plus 3, 6 oxygens, but I have 4 groups of them in total 4 compounds, so 6 oxygens times 4, 24 oxygens in total. Okay, so some of those are a little tricky, especially this last one, but try to work inside it, cover up the coefficient first, figure out how many of each you have, and then apply that coefficient. Okay, so on the next side here, what you do here is counting atoms worksheet, just kind of working with that. So for example, here I have some, now you can use the element symbol or write out the name, it doesn't matter, but we have Na here, of course, and if you look here, we have 2 of them. And then 1 carbon. And of course, if we look there, we just have 1. And then oxygens there, the last one. And of course, there's a 3 after it, so that means we have 3 oxygens. So in total, 2 plus 1 plus 3, total of 6 atoms in total in a sodium carbonate. So work through this sheet, gang. Some of them do have coefficients in front. Careful with some of these last ones here, they can be a little tricky, but I think you should be able to handle it. Okay, we'll see you later.